Andromeda, the giant spiral galaxy, is the closest major galaxy to our own Milky Way. It stands out in the vastness of space as the most distant object that can still be seen with the naked eye on dark, clear nights, far away from city lights. Impressive in both its form and details. Andromeda is not only massive but also hosts numerous smaller satellite galaxies, countless globular clusters, and a nearly uncountable number of stars scattered throughout its grand structure. Yet there is a fascinating fact about this galaxy that not everyone knows. While we remain safe for a very long period of time, Andromeda is actually moving gradually closer to the Milky Way. In a distant future, the two galaxies will collide, giving birth to an entirely new galactic structure, transforming both into something never before seen. Welcome to the Astronomy channel, your place for astronomy. If you enjoy topics related to the universe and all of its mysteries, then after watching or reading this content, consider subscribing here to the channel if you have not already. Together we will continue to explore the cosmos in greater depth. Although several dozen smaller galaxies are closer to the Milky Way, those are known as satellite galaxies. Among the great spiral galaxies, Andromeda is the closest one to us. The Large and Small Magellanic Clouds are closer, but those are irregular galaxies visible only from the southern hemisphere. Excluding them, Andromeda takes the title of the nearest spiral galaxy. It is also the brightest and most easily visible external galaxy in our night sky, in locations far away from light pollution. The human eye can spot it without any optical aid. If you have at least a pair of binoculars, you can see it in far greater detail, with its faint glow stretching wide across the darkness. Andromeda is about 2.5 million light-years away from us. That means it is bright enough for us to see even at such an incredible distance. In fact, Andromeda is the most distant object visible to the naked human eye. And what is even more astonishing is that its apparent size in the sky is actually larger than that of our own moon. The Milky Way and Andromeda are the two principal galaxies of what astronomers call the local group of galaxies. Among them, Andromeda is the largest and most massive. Our own galaxy, the Milky Way, contains an estimated little over 100 billion stars spread across a diameter of about 120,000 light-years. In comparison, Andromeda contains nearly 1 trillion stars and spans a diameter estimated at around 220,000 light-years, almost double the width of our galaxy. This makes Andromeda not only larger, but also far more populated with stars, clusters, and satellite systems. As mentioned earlier, Andromeda lies some 2.5 million light-years from Earth. To put that into perspective, even if it were somehow possible to travel at the speed of light, this is of course, from the perspective of someone on Earth. From the point of view of travelers moving at such speeds, relativity introduces additional complexities. If you are interested in a deeper understanding of what traveling at the speed of light would actually mean, there are entire studies and explanations dedicated to it, and this subject is often discussed in scientific videos and lectures because of its profound implications. Like the Milky Way, Andromeda also has a large family of satellite galaxies. It is known to have more than 20 dwarf galaxies orbiting around it. These smaller companions are strikingly similar to the dwarf galaxy population surrounding the Milky Way, though in Andromeda's case, they are more numerous. The most famous and visible of these are Messier 32 and Messier 110. Evidence suggests that Messier 32 once had a close encounter with Andromeda in the past. It may have originally been a much larger galaxy that lost its stellar disk after being torn apart by Andromeda's immense gravity. This event triggered a burst of star formation in its central region that lasted until relatively recent cosmic times. Observations also show that Messier 110 seems to be actively interacting with Andromeda today. Astronomers have even identified a stream of metal-rich stars flowing out of Andromeda, suggesting that these stars were stripped away from satellite galaxies during gravitational encounters. Messier 110 also shows a band of dust, which may be an indication of recent or ongoing star formation, further evidence of the dynamic relationship between Andromeda and its satellites. In comparison with our Milky Way, Andromeda appears to be made predominantly of older stars. Its overall luminosity is estimated to be about 25% greater than that of our galaxy. Interestingly, while Andromeda is larger and brighter, its rate of star formation is slower. In the Milky Way, about 3 to 5 solar masses worth of material turns into new stars each year, whereas in Andromeda, that rate is only about 1 solar mass annually. This indicates that Andromeda underwent a significant period of intense star formation in the past, but is now in a relatively quiet phase. Meanwhile, the Milky Way continues to actively form stars at a faster pace. Astronomers have confirmed that Andromeda contains around 460 globular clusters. Among these, the most massive is known as Mayol 2, a globular cluster with luminosity greater than any other globular cluster found in the entire local group of galaxies. It houses several million stars and is about twice as luminous as Omega Centauri, which is the brightest and largest globular cluster in the Milky Way. My-all-2 is so massive and complex that many scientists believe it may not be a typical globular cluster at all, but rather the remnant core of a dwarf galaxy that was consumed by Andromeda long ago. Because we view Andromeda from the side, analyzing its spiral structure is a challenge. Corrected astronomical images, however, suggest that it possesses a fairly conventional spiral structure, with two main arms extending outward for about 13,000 light-years and traceable up to 16,000 light-years from its central nucleus. Observations made with the Spitzer Space Telescope in infrared wavelengths have confirmed that these two spiral arms appear to emerge from a central bar and then extend well beyond a massive outer ring. At the very heart of Andromeda lies a compact and densely packed cluster of stars. Surprisingly, it revealed a double-core structure with two bright regions separated by about 4.9 light-years. The brighter region, known as P1, is slightly offset from the true center of the galaxy, while the dimmer region, P2, lies exactly at the core and is home to a supermassive black hole. Astronomers proposed that this double-core effect could be explained. If P1 represents a projection of a disk of stars orbiting eccentrically around the central black hole, the eccentricity is so extreme that the stars linger at the farthest point of their orbits, creating the illusion of a concentrated bright spot. Some scientists suggest that this eccentric disk may have formed as the result of a past merger between black holes, where gravitational waves kicked surrounding stars into their current configuration. Andromeda is moving toward the Milky Way at an incredible speed of about 110 kilometers per second, as shown by its blue shift, the change in wavelength caused by motion toward the observer. Using the Hubble Space Telescope, researchers measured the positions of stars in Andromeda in both 2002 and 2010 relative to hundreds of distant background galaxies. By averaging the motion of thousands of stars, their results show that Andromeda will inevitably collide with the Milky Way in about 4.5 to 5 billion years. Current models predict a 50% chance that the solar system will be flung about 3 times farther from the new Galaxy S center than where it resides today. There is even a 12% chance that our solar system could be completely ejected from the merged galaxy during the collision. Such an event would not necessarily have destructive effects on the Sun or the planets, but it would dramatically change our place in the cosmos. By the time this galactic collision occurs, Earth will already be facing a grim future. Scientists estimate that within about 500 million to 1.5 billion years from now, the Sun's gradual brightening will make Earth's surface too hot for liquid water to exist. By the time Andromeda finally collides with the Milky Way, the Sun will be about 35 to 40% more luminous than it is today, likely triggering a runaway greenhouse effect that would have already transformed Earth into a hostile world. Simulations suggest that the ultimate product of the Milky Way and Andromeda collision will be a giant elliptical galaxy, though with the center less densely packed with stars than current elliptical galaxies. It is also possible that the merger could form a large lenticular galaxy or even a superspiral, depending on how much gas remains in both galaxies when they collide. Over the following 150 billion years after this grand merger, the remaining galaxies of the local group are also expected to merge into this single colossal structure. If you enjoyed this exploration of Andromeda and its eventual fate alongside our Milky Way, every like, comment, and share helps spread curiosity and appreciation for the cosmos. Thank you very much for being here, and until next time, keep looking up at the stars.